Hello everyone and welcome to the flipped classroom. Today we will begin our first set of notes over 1.1. Remember, at any time you can stop the video, you can rewind the video, you can fast forward the video. So anything you need to do, you can do that, and you can watch it as many times as you would like, over and over and over again. So we're first going to get started with the basics of where geometry starts and how all of our shapes that we're going to be talking about, how they just all come together and how they form. The first definition we are going to use is point. What you want to write here, so you can either fill in the blanks if you have printed it out, or you're going to write all of this in your notebook. So a point, and excuse my handwriting, I haven't done this all summer long, so it's going to take me a few times to get my handwriting nice and pretty again. A point has no dimensions. It is represented by a dot. The way that you draw, the way you can draw that is you simply draw a dot. You draw a dot, and then you have to give it a name or a letter. So this would be point A. So that's how you would read this out loud to me, and that's what's going to be very important, is you're going to need to know all year long how to recognize these symbols and be able to say them out loud or in your head to yourself. So this is read as point A. Next, so everything's going to build on one another. So the next thing we're going to talk about is a line. So a point has no dimensions. Then next we're going to go to a line that has one dimension. So a line is represented with two arrowheads, and it extends infinitely in one direction, in both directions. So it extends infinitely in both directions. So the way you draw a line is just like it says. It's going to be a line. It's going to have two arrowheads, but you have to give the line a name, and there are two ways you can do that. You can put any 2 points on the line that you want, and we could name it in that regard. So we can call this line AB. Another way you can is to go ahead and write the symbol. So if we wanted to write shorthand, we would use the letters A and B, and then we would put the line symbol over the top. And again, it's going to be important for you to be able to, when you see that symbol, say back to me, read in your head, make sure it's line AB. Another way, since you can write this, is since the arrows mean it goes infinitely in both directions, you can also write the name in both directions. This doesn't apply to everything we talk about. This only applies to the line because it is going in both directions. Now, another way you can also name a line is to use a little letter that's usually lowercase or kind of italicized out to the side of the line. And if you wanted to name it by that letter, you would have to write out the word line and then use the letter M. So these are the 4 different ways that you could name this one line. So you are going to be asked a couple of times. You're going to be given a line, and it's going to say name it a few different ways. Line AB with the symbol, line BA with the symbol, or if it does have a subscript, you can use that. And it's not always going to have that little letter, just sometimes. Now we build. So we go from no dimension to one dimension, and now we're let's see, I'm getting ahead of myself. So through any 2 points, there is exactly one line. So what this is basically saying is that no matter where the 2 points are, how far they are apart, where they're at in outer space, if there are 2 points, you can draw exactly one line. So if you had one point here, and then you had another point over here, if there were 2 points, then you can go ahead and say, okay, I can connect those and I can make a line. So that's basically all that's saying. And again, there are so many ways you can name it. Also, if there can be an infinite number of points on any line. So we could have a R, we could have an M. You only need 2 letters. You don't need any more than that. And basically, you can write them in any order. So we could call this line SR. If we still use the symbol, you know, we could call it TS. So any two of those letters, we could say MR. So hope you get the point. Any two, any direction. Now, we go to 2 dimensions, and that's going to be called a plane. So a plane is represented by a shape, and most of the time what you're going to see it look like is in a square shape, or more like a parallelogram that's tilted, or it also looks like the floor or the ceiling. Because a floor and a ceiling, they are planes. Okay, but it extends without end, and through any 3 points, as long as they're not on the same line, any 3 points, there's exactly one plane. So you can use 3 points that are not all on the same line to name a plane. So let's look at what a plane is going to look like when it's represented like on a piece of paper or in a book. It's going to look more like a square. It's going to have it can have a bunch of different letters. You know, it has an infinite amount of letters here. It can also have a letter in the corner, okay, that is not going to have a dot by it. So to name a plane, you need any 3 points. It doesn't matter what order. So some ways to name this plane, you could say this is plane RST. You can use any other letters. We could go VTS. Then another way you can name a plane is if it has a little letter in the corner without a dot, you could just say this is plane M. We could not say it's just plain R, S, T, or V because those are all points. It would have to be the letter in the corner without a dot by it. So what the second sentence means is if there are any 3 points, it doesn't matter where they're at. Okay, M, N, we could have one up here, O. Through any 3 points, you can make a plane. So you can draw a little box around them and make yourself a plane. So any 3 points in outer space, no matter where they're at, as long as they're not on the same line, you can call that a plane. Now, points that are on the same line, they have a special name. They are going to be collinear points. So what's important about this is think about the prefix here. Co means together and linear means line. So they are all points on the same line. So you can, it really just looks like a line. So if we have points A, B, and C, and you might have a question like, are they collinear? Yes, these would be collinear. If we had another drawing of a line, and we had A, B, or C, and then we had B, are these collinear? This would be a no. These are not collinear because they're all not on the same line. So similar to collinear is also coplanar. So again, co, the prefix meaning together, planar is for plane. So coplanar points are points that lie on the same plane. So if you had a plane, and you had all of your letters here. All right, it would say, are those points coplanar? Yes, if you came across a question like that. And if we had another plane, and it doesn't matter what you're naming these letters, you can name them really whatever you want. And then let's say we had a Z out here. Are all these points coplanar? This would be a no, because Z is not in the plane. Alrighty, a segment. A segment, or it's also sometimes called a line segment, mean the same thing. It consists of 2 endpoints, and all points on the segment are between the endpoints. So a segment is kind of just a piece of a line, and it has a definite end and beginning. So here you have 2 endpoints. So the dots are what are endpoints, and we would have A, B. So to write this out, you would just use the letters, and this would be segment AB. Now, the way you represent a segment is you put a bar over the top. You need to make sure you know the difference. You need to make sure you can actually read that as segment AB. Now, you can also flip the letters around, and this could be segment BA. We typically don't write the word segment and then use the letters, but you can. It's not wrong like we do with line. We do it more so with a line than we do with a segment. And usually segments don't have the subscript, so this would kind of be the only two ways to name this segment. All right, kind of combining a segment and a line is a ray. So a ray consists of one end point and one arrow. So it's going to have a beginning point, that's the end, okay? And I want you to think, I know it's really weird, but this end is really the beginning. Okay, so this is where the ray is going to start. And it extends on infinitely in the other direction, and infinitely in the other direction is represented by an arrow. So the way a ray is drawn is you start with the end point, and then you extend on infinitely in the other direction. And you need two letters. Now, it is very specific how you name a ray because it has two different things going on here. It has an end and an infinitely in the other direction. So you must name it. The arrow must go in the direction that it is in the diagram. So this would be referred to as the diagram. And then I'm asking you to name it. You have to name it in a specific way. Since end is the M, you must draw the arrow going towards the N. Has to be that way. Now, the picture does not have to always be going to the right. It could also be going to the left, and we could have other letters here. Because if your arrow is going to the left, you're still going to write it the other way. So we're going to start with the letter Y, and then our ray is YZ, and you ask yourself, okay, well, what direction is the arrow going towards? Well, it's going towards the Z. So we would draw this in that direction. So typically when we draw rays, we draw the arrow pointing towards the right. No matter what the diagram looks like here, we're still going to draw that arrow to the right, and then just make sure the letters follow in the correct direction. Now, when we have two rays, they can get special. So two rays that are collinear, and this is very, very important because this means they must form a straight line. All right, if there are two rays that are collinear and they have a common end point, they are called opposite rays. Opposite rays extend on infinitely in both directions. So if I were asking you to draw a picture of opposite rays, you would start with a line and basically put 3 points on it. So we could say P, Q, R. Now if I asked you to name two opposite rays, you would need to start with the letter in the middle. So we're going to start with Q, and then we're going to go in one direction. So QR. This is one ray. Make sure your arrow's going towards the R. Then if I wanted to name something opposite to QR, you have to use the same end point, but then we have to go in the opposite direction. So that would be QP. And this is what kind of gets a little confusing because you're sitting here telling me that these are opposite rays, but look, our arrows are facing in both directions when we kind of write the names of them. So it can get a little confusing. Just maybe always look back at your diagram and go, okay, QR is going to the right and QP is actually going to the left, but this is the way we write things. A picture of not opposite rays, it could be a lot of things. You could have a diagram like this that had a P, a Q, and an R. All right, and these would not be opposite rays simply because they're not in a straight line. These are not collinear. Remember, it has to make a perfectly straight line to be opposite rays. Alrighty, so now intersections. So two or more geometric figures intersect if they have points or line segments in common. Okay, the intersection of the figures is a point or a set of points of the figure that they have in common. So the intersection of two lines is a point. So think about how I told you everything built on itself. We start at point, then we go to line, and then we go to plane. And then eventually we're going to build a bunch of planes together, and 6 planes make a cube and stuff like that. All right, the intersection of two planes is a line. So to draw a diagram of the first one, so we draw two lines. So you see how immediately, like when you draw the two lines, then they're intersecting at one point. Right here is the intersection. Okay, and this can be line L and line M. I don't want to put all the points on there. Too much time, not enough room on my diagram. So you could say that line L and line M, all right, they're going to intersect at point D. So two lines intersect at a point. Now two planes, it's a little bit harder to draw those, but we're going to do the best we can do. So we have a plane, and then we're going to have another one kind of cutting through it. All right, so it's going to cut through, and we're going to kind of show that by a dotted line. All right, it's cutting through there. So these two planes, if you think about like the letter X, like a three-dimensional letter X, and you think about where it's crossing right there in the center, where it's crossing, all right, is this intersection, this line right here where everything touches together. And you see that it's not just touching at one point, it's touching at an infinitely amount of points all the way through that. If you were like to push a piece of paper through another one, they'd be touching at every single point. Another way to think about this one is if you were to think about like the walls, okay, of your classroom, and then you were to think about the floor of your classroom. And think about this. If you have a wall and a floor, one little point is not going to be able to hold all of that up. You're going to need a lot of points, an infinite amount of points to hold up the wall and the floor. So that's kind of how I always remember that they're two bigger pieces, so obviously the intersection is going to be a lot larger than one point. So let's see, let's name some of these things here. So this could be oh, you can't really see that. Let's see. So this could be plane R, and we can name this L, and let's say line A. So plane R and plane L, all right, they're going to intersect at, running out of room, line A. There you go. Remember, you can rewind, pause, fast forward as many times as you need to. Hope your first flipped classroom experience was a good one. Thank you.